see so many friends. Today I'm going to show a variety of sort of less technical work and maybe more work in the area of tactical media, all created as part of the Free Art and Technology Laboratory. The main themes of the work I'm going to show today are graffiti, information visualization, and digital fabrication. And to begin with, I'm interested in combining the visual languages of data visualization with the communication strategies of urban markup. So these two languages don't usually collide, but they should. Messages of protest should be backed by data. And this is especially important for an era in which people have such a weak grasp of numbers that matter. So this is a project is an adjustable pie chart stencil. Everything is laser cut from a single sheet of material, and the stencil can be easily reused for different messages. It can be used to create situated information visualizations in which the visualization relates in a thought-provoking way to the architectural program of the location where it's deployed. So there's many possible messages, each of which can be cut from a single sheet, and the arm can be adjusted to any different position. So we've always been confronted with corporate messaging in cities, but they've recently taken a particularly dehumanizing turn, I feel, in that they're now intended for reading by machines. And there seems to be no place for everyday people to make their own voices heard in the medium of QR codes, this kind of visual pollution we see all around us. I don't find that necessarily to be an inspiring view. The question is, how can we take this back? And so by contrast, I've been inspired by Hobo Codes, which became widespread in the early 20th century. These are a form of civic markup that guides vulnerable migrants. They say things like, talk religion, get food here. And they're still in use today. The ones on the right are from Canal Street. So this set of codes are basically informal chalk markings that are used all over the United States. So I developed some free software that makes it easy for everyday people to create and laser cut their own QR code stencils, which is a fast way to make very large and accurate images. My software uses simple computer vision techniques to resolve and automatically bridge the islands that make stencils ordinarily so hard and tricky to design and fabricate. And here you can see it's laser cut out of a sheet of MDF. So the software has been released with a set of 100 free QR Hobo Codes, which are a set of urban markup tools for digital nomads. They have messages like buyer beware, free Wi-Fi, no changing table. And again, they allow for a kind of situated information visualization driven by civic concerns and conscience. So a different kind of graffiti. Recently, I've been inspired by my 5-year-old son, Zen, who's observed that he was able to make a more subtle form of urban markup. He asked me if I could use my 3D printer to make shoe soles with his name. And this began a whole new research project. It turns out that some new 3D printers can actually print rubber. And so my son's request seemed to be as good of a place as any to develop a new piece of free software which generates 3D models for shoe soles, rubber stamps, toy wheels, and car tires. In this case, it's showing a tire, but it can also do shoe soles, it can do rubber stamps, and it's built-in processing and basically exports STLs using some of Marius's code. And here coming up is an example, a Lego wheel in this case, part of a self-inking toy robot car that we'll be publishing shortly. This is done with Randy Sarafan and Jordan Parsons. You can see that it's leaving an imprint, in this case in ink, but it can do equally well with paint, in dust, in sand, or in snow. And stay tuned, we're about to release free methods and software for producing text on shoe soles and also large-scale wheels as well. Now, another project inspired by the needs of my son, you all know these, toy construction systems. They allow for infinite recombinations of form. Or do they? Each presents its own universe, but where are the wormholes that connect these universes? Each company would like to have you believe that it's the only possible kit that could exist, and the others are just elephants in the room. So this is the problem. Toy manufacturers have little or no intrinsic motivation to make their products compatible with anyone else's. In fact, this is true not just in toys. So despite obvious benefits to users everywhere, the implementation of cross-brand interoperability can be nearly impossible, given the tangled restrictions of patents, design rights, and trademarks involved in doing so. So we stepped up, and we created the free Universal Construction Kit, developed with Sean Sims. It's a set of adapters that allows for complete interoperability between 10 different construction toys, for example, like Lego and Tinker Toys, Fisher Technic, and so forth. By allowing any piece to join to any other, the kit encourages totally new forms of intercourse between otherwise closed systems. Now, reverse engineering commercial toys proves to be actually more difficult than we expected. Our first attempt used calipers, which are accurate only to 1/100th of an inch. It failed. Our second attempt used micrometers, which are accurate to 1,000th of an inch. Finally, we discovered this thing. It's called an optical comparator. And if you're interested in reverse engineering toys, it's accurate to 100,000th of an inch. So they actually work, and anyone with a desktop 3D printer can download the free files, print a copy for themselves. For me, this demonstrates this notion of engineering and reverse engineering as a civic activity in which everyday people create local solutions to local problems and creatively overcome limitations of mass and consumer media. Thank you.